Okay, Johnny Pillar here down at Powerhouse Engines on a Saturday morning, and I've got something exciting. This is going to be our third YouTube video for the new channel, and I'm going to teach you something about cam to crank centerline correction. I've been lucky enough through Craig Bennett, this is Craig Bennett from Torque Power, to hook us up with this BHJ fixture, which come from John Sydney's.
Yeah, it come from John originally, yeah. John made the bench. He bought the fixtures from America there, and then he got the old Repco type head borer here for boring for the block, and made it all fit, and so that the it could cut the tunnels on the blocks. And it was mainly because of the technology of the cam bearings have gone from old white metal to roller bearings today. And so this machine here, and you'll probably see later on, you'll see pictures and videos of John doing the work on it. But yeah, the block will sit in there upside down, and then you'll have your saddles like these will go on here, all different heights, crankshafts there for the pin, and then of course the big cutter will go through to do all your sizing of whatever bearings you're going to use, if it's 55mm, 50mm, whatever. John can do this machine here. They used to do FE motors, big block Chevs, whatever you want to do.
Yeah, so with this, a bit of a story with it was, I actually seen the machine at John Sydney's and knew that Mick used to do a lot of cam tunnel work, but the company that actually makes this machine, or this fixture, BHJ, as of this year, they've shut down, so we can't even buy this new. And the only other guy I know that's actually got the fixture is Charlie Sleeber, as a really nice unit. So when Craig and John were really good friends, unfortunately John died, and Craig bought the machine, and then as soon as I heard that, I called Craig, and I knew he wouldn't be interested in selling it, but I just said, if you ever do, can I just have first option on it, which he said he would. And since then Craig's bought, what's the new machine you've got, Craig?
I bought an NH Morosiki, a 5000, and I also replaced this because I make my own blocks, the little paw block and big paw blocks. If you follow Torque Power, you'll know what I do. And I actually bought a line, I sold this to John, and then I actually bought a line hone machine, which was probably more beneficial because now I can do the Torque Power block from start to finish in-house.
Yeah.
So, but I don't know if Charlie's, I've never seen Charlie's, but did Charlie have
done
this
the same thing? Well, Charlie,
like this?
Apparently the story goes, Charlie put the bore and bar on his to do that, and then John, and obviously Charlie and John knew each other.
Yes.
And then and then John goes, that's a great idea, I'll go do that myself.
Yeah.
And did. And
it is a great machine.
They are awesome. And the interesting thing is, I'm going to show you, there's a lot of people out there doing cam tunnels like in conventional line borers, like our line borer. We've got the Sun in there, which is a beautiful machine, but there is no actual way to get that cam tunnel dead in line with the main tunnel. Like, you can clock up off what's already there, but with this particular fixture, as we'll show you, the cam tunnel's in line with it as far as position goes, the right centre height, but also in line with the main. There's no other way of doing it that can actually do that. So we're going to put a block in, we're going to show you, we'll clock it at the front, clock it at the back, and you'll love it. So that's probably about it. So Craig, we've also been talking all morning about the things we've got going on in the engine game. You've got heaps of exciting stuff other than obviously the intake manifolds and the block that we all love you for. Tell us about what else going on.
Yeah, for probably a lot of people, I don't really advertise heavily, and for people that in the Chevrolet side of things, mostly people know of Torque Power because of the Holden. Torque Power, I probably make, I do make the most parts in the world for Holden. You know, I have 9 series of heads and 20 different manifolds and blocks, and it all goes on. We make our own camshafts, we make our own engine, really. But around about 2 years ago, I purchased, for guys that are in Chevys, small block, I purchased Racer Pro cylinder heads from the founder, his name was Paul Wilson. And that's been going on in the background. John knows about it. There's a range of heads, and we've modified them a little bit so that they're up to speed with one-piece rocker rails for stability and all that kind of stuff. And so there's 23 degrees, there's raised 23, and I'm pretty sure that we're the only ones in the world now with a raised 23. Brodex used to do one, but then they went to a 20 degree for some reason, I don't know. We have an 18, we have 15s. We also have made this, in the package, there was a symmetrical head. And when I mean by the symmetrical, it's like a Chev head, but it's like a Holden VM or a Ford. It's a killer. It'll be a killer head.
So I've seen Craig was showing me the flow numbers of this thing before, and it's next level. I haven't seen a port with that sort of cross section move that amount of air. So I'm hanging to get one on an engine.
It'll be a good thing, And we will eventually make a manifold for it, but you can buy manifolds for that head. Like Brodex made a head, and it's called a BD 2300 or a BD 2000 or something like that, and that's a symmetrical head. And there are manifolds there that will suit that style of head. But I think that we can make a better manifold once we have the head done, finished, water jacketed. I think we can make a better manifold to suit. Then we can play with manifold, head on the flow bench, that kind of stuff, and then dyno testing. Everything that we've ever made it's always been dyno tested before I even put it on the marketplace.
Well, the biggest thing I love about the product is one, it's Australian, and it's always quality. There's not once we've ever pulled a torque power manifold out or a cylinder head and you can fault it. So companies like this, really like supporting them, and I think a lot of other people in the game are seeing that this stuff coming out from overseas isn't what it's cracked up to be. So we really appreciate what you've done for the Holden V8, because you are keeping the Holden V8 alive. If it wasn't for guys like Craig, we'd be stuck with a couple of manifolds to pick from and combos that are they'll never reach their full potential. And like with this small block Chev, I love a Chev as much as a Holden. It's going to be good times ahead. There's
also the aluminium, like John just said. There's also a small block Chevy aluminium block.
That's exciting. Aluminium small block Chev. Just to replace like a Brodex.
It'll replace like your Donovan blocks, but there'll be a few options. So if you wanted to use it for your street car, yes, it'll have availability to have a starter motor on it. If it's going into a sprint car or something like that, then yes, that'll be all machined and profiled at the back where we don't need any starters for lightness and everything. The cam will be raised. I don't believe that any block today that's made really should have a standard cam bearing heights.
Madness.
So, because the problem is with it, that a lot of people don't tell you, is yes, in the early days when I was working in the States and that, yes, we did have standard centerline. But the problem is, yes, you can put a bigger arm and you can stroke them. But the problem is, as John knows, conrod comes around, hits the cam. So what do people do? Grind the cam down. The next thing you know, you've got a base circle.
You got a 750 base circle and nothing breaks them up. So as we've learnt in other videos gone by, the bigger the camshaft core, the better it is. And
that's exactly what this machine's to do. This will do it.
So this is a type of machine that you want to be doing that kind of work on, not a conventional line borer.
Even if a guy's in a bracket class and he's only allowed to have 5 litre, or he's only got a 350. Well, this machine here, you can still go and just put it in for standard centre lines if the class says it has to be. But he can bring it out to 55 mil. He can have that technology, the stability of that the train on it, the valve train, and it's got it's far superior. You're not having to have one of the good things about this is when you do put the roller bearing in, as you know, you don't need the oil. So it blocks the oil hole off, so it just helps the oil go to the crank more again.
So there's a lot of
lots of benefits.
So we're going to show you a video. We're going to really break it down and show you every part of the process. And obviously I really appreciate the comments and the involvement for the last couple of vids. And Craig, thanks once again. Thanks for giving me the opportunity to buy this thing off you, because honestly I was chasing it for quite some time, even when John had it. And anyway, it's now with BHJ shut down, there's not even the opportunity to buy
I didn't even know they shut down.
They did. So it happened around PRI time, and I actually went to to BHJ because I was sort of in the area. I had to drive about 8 hours.
Yeah.
And just went through the shop and they gave me a tour. And I was just shaking my head, just thinking like
Yeah.
the company that's been going so long
Yeah.
and making like really good products.
Oh, beautiful product. Beautiful.
Yeah, it's all over. So anyway, we're here to keep the industry alive, and yeah, thank you for the support. I'm going to show you this machine in action. So first thing we got to do, you got to do your tunnel work first. So the block's got to be line board, line home. That's all got to happen first. So obviously the idea of this is to get our correct centre height. So we've got a 2-inch precision bar in here, which is dead straight. And then we've got our main tunnel rings, which we made up for pretty much every engine in thou increments to cover every sort of engine that we work on. So I've got these marked front and rear, so they always go back same, just for repeatability. So we just a little bit of oil on there, a little bit of oil on the front one, and then we slip them on. And as you can see, I've machined a couple of flat spots on the side, which the idea of them is just to line up across the parting face of the block, so they all go in there the same every time. Right, and once they're in, then we can get this cap. Right, put that down there. And always a good check once we've got the rings in is to just give the bar a bit of a spin, make sure it spins nice. If it doesn't, something's not right. It's the cap's not locating properly, or the tunnel's not the right size, or something like that. So what we're going to do, we're going to get the rings. So we've got these bad boys here, which are the spacers. So this one runs, so same sort of thing, we'll just oil it up gently. We'll pop them on there. Now all these are made for different engines. So as you can see here, it's Chevy big block, then we've obviously got small blocks, we've got Ford, got pretty much all the common V8 stuff that we work on day to day, LS. And these are crucial. That they're accurate, and don't worry, I've been through every single one of them, measured them all up, and made sure they're all still good. So what we're going to do, we're going to jack this block up, hang it on the crane, and we're going to drop it into the machine, and we're going to show you the setup. Okay, so a bit of a wrestle to get it into the machine and just get everything lined up as we're dropping it onto the dowels, but it's like a 3-man job. But now it's in here. What I really like about this machine is it's super quick just to get a setup. A little bit of mucking around to dial the block in sideways, but as far as, check out this, just sit the thing in here and it's just rocking, and that center height is set. It's set off the clamps. So my job now is to dial it in sideways from side to side, and then how much up and down is what we're going to be correcting. So I'll show you how we do that, and then yeah, we'll get it done. Okay, so as you can see, we're about 32 thou out. So we're going to loosen these clamps off. We're going to kick the block. We're going to do these up. Try it there. Okay, so we'll zero that out. and we'll roll it sideways. As you can see now, I've got that thing pretty much on the money, and I'm going to do this end clamp up, which holds pressure on the block in that direction. So these are all nipped up. The end clamp's done up, and then we'll double check where we're at. Okay, 0. And then we're 0 there. Okay, so this is the interesting part. So obviously the block's clocked in. What we want to check is how far out it is this way. So let's go to let's 0, say the bottom. Probably easy to see it like that. Right, so that's zeroed out. Then we're going to roll it to the top. And that's what we got. So we're about 4th hour. 4th hour out, up and down. Right, which that's cool. That's sort of to be expected. Now we're gonna take the same setup pointer. I'm gonna put some oil around it on the other end. Now this is a bit that's going to be really interesting. I'm gonna pop this in. And there with a screwdriver and just pop that down so it sits in the front cam bearing hole. Right, now we'll go to the bottom first and we'll 0 the gauge out. Hold on, Jay. Okay, we're going to 0 that, and then we're going to roll it to the top. Right, so as we can see, this end of the block is actually 8th hour. So what that means is the cam tunnel in this actual block is like that. So it's not running in line with the main. But the interesting bit, let's have a look at how close it is side to side. So we'll zero this out, and we know we'll 0 at the other end. Okay. So what's that, Jay, about a 5? About a 4.5 or 5? Okay, so with this basic setup, you can see that not only is the cam tunnel like that, it's also like that. If the cam tunnel is true, I would 0 one side of the gauge, and then I'd roll it over 90 degrees, 180 degrees, sorry, and then it would be 0 as well. So the fact that it's out that way and that way, that's what we're correcting. So yeah, this is a big block Chevy, one of the import blocks, but a lot of factory stuff's exactly the same, and this is the machine to fix it on. So I've got to get on the engine dyno, so I'm going to get Trevor here to run the bar through, and Jay will show you the process and the cutter set, and then we'll bore it to oversized back. This particular block we can't go to 55mm because it's too small in the casting to go to that big, but we'll go to like a 10 or a 20 thou over just to clean it up and get it true. And then the timing chain is going to be perfect. It's going to have the right length and the right distance between crank center and cam center, and it's going to be perfect in line with the main tunnel, which is what this bar is all about. So that's the way that you correct the block properly. Yeah, can't really do it on a line borer this accurately, and that's why we're doing it like this. Okay, down in the Powerhouse again. Now something really interesting happened after we machined that last big block, which was a Chinese knockoff of it was like a Gen 6 block that had a one-piece rear main seal. So the next job I had to do in the machine was just a Dart big block Chevy, going to 55 mil. Anyway, put the thing in there, set it up. And what we found is the cam tunnel was very similar to the other block. It was actually crooked that way about 10 thou, and the centre height between both ends wasn't right. So then I just started questioning myself whether maybe the jig's not right, because I didn't think a Dart block would actually be out. The fact they're done on late model machines and they're done by Dart, I thought there's no way. It's got to be maybe John Sidney and Mick have been boring all these blocks over the years, and the machine hasn't been right, or the jig hasn't been right. I know Charlie Saliba, when he bought his BHJ jig, he measured it up and it was out, and he actually ended up making oversized rings. He put it in his line borer, he offset it, and then he just remachined it and then corrected it all. And I'm thinking, oh no, I'm hoping that's not the case here. So the first thing we did, we checked both bars for run out, which I'd already checked the main one. I hadn't actually checked the boring one. And then we put a micrometer across the top here, and then it was very hard to get a good feel, but before I had Trevor. And then we had a number there that was nice, and then we went up the other end, and the same thing. We got that same feel, and so we know that the cam to the crank is the same end for end, which obviously depends on how well these spaces are made too, but in this case it's bang on. Then we end up clocking the bar up, so basically ended up knocking this around into position, so the bar was running dead true, right? So that gauge is in tenths, so from 0 to 1 is 1 thou. So as you can see, there might be a temp in it, how we've got it set up. So then we come across here, and then we go back to the start. It's not touching at the moment. We come down to the cam tunnel bar. So this is the one that does the boring out. Right, we bring it in so it's close, and then you'll see we'll find the high spot of the bar. Can you see the gauge shape? Alright, so right there, the gauge is about to go back the other direction. So what we'll do, we'll zero that out, and then we'll run it. Right, so I was going to go over a little step here in a sec. Oh, it goes back. Alright, let's double check that. Actually, okay, so it's about 2/10 in it from front to back. So I know that this is lined up. It's within 2/10. We're talking a brand new Dart block is out 10 thou. So it's not the jig, it's actually in the block, which is a little bit disappointing. But luckily we've got the gear to fix it, and we'll get this thing spot on. So something to look out for, even when you're buying brand new checking fixtures. Got to make sure that they're right. All right, we're back in the machine shop here, and we're working on the Dart big block we're talking about. Now, we've checked the jig, obviously, and we know that's spot on. And I've just had Jake clock up this end. So this is the front of the block. So what we're doing, we're checking it at basically like 3 o'clock, and the gauge is on 0. I'm going to roll this thing around to the other side. And as you can see, we are at 0 on the gauge. So the center is perfect. Now, how is it up and down? Now so what I'll do, I'll go to the bottom. I'll zero that out at 6 o'clock, and then we're going to wind it to the top. All right, so we have a look at that. That's 8 thou out. All right, so obviously a couple of thou of that is going to be in the block being line honed, but it's a little bit too close center to center. So now, this is the thing that really interests me, which blew my mind. I can't actually believe this is the case. We're just going to put a little bit of oil on the thing here. Rub that in. Just going to drop this in, and then just use a little screwdriver just to pop that pointer in. Right, I'm going to make sure that's in a nice part of the block. All right, so if you come around here, now, so that's on 0, right? So let's spin this, so we're at 9 o'clock. We're going to spin this around. And check out that. So that's 8. 8 that way, and then we're going to go to the bottom. 0 that out, and then we're going to roll it to the top. And we're 4 out of the top. So once again, a bit like the Chinese block, out of alignment that way to the main tunnel and out of alignment that way. So it might be a dart, but they're still not perfect. That's why they make machines like this to blueprint these engines and get them 100% right. And then obviously after that, we're going to go through and we're going to do lifter bores, put some bronze bushes in there and get them right. So, that's what it's all about. And thanks for watching.